So let's look at our first proof example. I'm going to ask you to prove that the sum of two even integers is even. So we're going to follow that procedure that we talked about previously about direct proof. So you're going to start by restating the statement as a universal conditional statement. So here, the sum of any two even, so it's going to be for all, and I need to choose letters, so I'm going to choose M and N. For all integers, M and N, if, I need to write it in an if-then form, if, what? If they're even, if M and N are even, then M plus N is even. So this is what we want to prove. So I'm going to ask a question now, always with these proofs. How do I start? So what we want to identify is the starting point of the proof. So if you remember, the method of direct proof tells us how to start. That's step 2. You're going to suppose that M and N are any particular arbitrarily chosen integers that are even. So you're assuming that they're particular, but you're also assuming that they're arbitrary integers that are even. So that tells you how you're going to start. So then, before we write the proof, we also need to ask, what's the end goal of our proof? So what conclusion do I need to show in order to complete the proof? So if we look at our statement in the end, I need to show that the sum is even. So I need to show the conclusion that we need to reach. Conclusion is that M plus N is even. So I know how to start the proof and I know how to end the proof. So then really all that remains is for us to connect the dots. So how do I get from the starting point to the conclusion? And so the answer is you're going to have to do some kind of scratch work to kind of connect the dots. So I'll call this my scratch work. So let's see, if I go back to what was the starting point, I assume that M and N were even. And we went over those definitions before. If they're even, that means they're 2 times an integer. So M is 2 times something, so I'll say 2 times R for some integer R. N is 2 times some other integer, 2 times S for some integer S. And now if I look at my conclusion, back up here, I'm trying to say something about the sum, so maybe I should add these together. M plus N, 2R plus 2S. And I want to conclude that M plus N is even, so I need to write it as 2 times a number. So what should go in this parentheses? R plus S. Essentially, we factored out a 2. And that will show that m plus n is even. So now we know how to get from the starting point to the conclusion. So I can now write the complete proof. So that's what we're going to do right here. Proof. And let's write it up. So we're going to start at our starting point. Suppose m and n are any even integers. And then what did we use here? Up here, we used the definition of even. So we'll say by the definition of even, m equals 2r and n equals 2s for some integers r and s, then m plus n, we said was 2r plus 2s, 2 times r plus s. And now I'm going to relabel this thing in parentheses here. I'm going to call it t. Let t be r plus s. Now we need to explain why t is an integer. T is an integer because it is the sum of integers. Hence, what do we have? We have m plus n equals 2 times t, where t is an integer, and that's exactly what it means to be even. So it follows, by definition of even, that m plus n is even. So when you complete a proof, we usually write a closed box at the end of the proof to signify that it's complete. Now, I do want to make a couple comments about proofs. So the first one is these proofs are essentially sentences, so you have to use words. You can't just write down symbols and equations. And number two, I see a lot of times students want to prove this by example. They want to take two specific even numbers and add them together. Well, that doesn't always prove that the sum of any two evens is even. Remember that an example doesn't prove that something's true in general.